Yes.
Good afternoon, all present here. Hi, Vedika Biswas. Still, a warm welcome, Dr. Basudeb, our esteemed guest for today's webinar on behalf of Symbiosis, Institute of Geoinformatics. I also welcome the placement officer and all the attendees of the event. Welcome, Dr. Bhatta. Indeed, an honor and privilege to have you amongst us. I'm delighted to introduce you to our distinguished audience. Dr. Basudeb Bhatta earned his PhD in engineering from Jadavpur University, Kolkata, India. He is one of the founders and current CEO of Spaten Geotech Private Limited. With over 25 years of industrial teaching and research experience, Dr. Bhatta has made significant contributions to remote sensing, GNSS, GIS, and CAD. Dr. Bhatta has served as a course coordinator of the Computer Aided Design Center at Jadavpur University. Throughout his career, he has published numerous research papers, monographs, and textbooks in his fields of expertise. Dr. Bhatta has been instrumental in initiating many courses on geoinformatics, GNSS, CAD, and related areas. His expertise and contributions have been recognized by several professional organizations. Dr. Bhatta is a life member of various national and international societies and a fellow of the Nikhil Bharat Shiksha Parishad. In recognition of his outstanding work, he was awarded the Outstanding Scientist Award by the BGJ Professional Association in their International Scientist Awards on Engineering, Science, and Medicine 2020. Dr. Basudeb Bhatta's extensive expertise and diverse experience make him an invaluable asset to our webinar. Today, he will be sharing his insights on unmanned aerial vehicles, which is UAVs for urban development, revolutionizing data collection with GIS and remote sensing, drawing from his wealth of knowledge in remote sensing, GNSS, GIS, and CAD. Please join me in welcoming Dr. Basudeb Bhatta to our webinar. Eagerly anticipate an engaging and enlightening session. Thank you.
Thank you, Ms. Biswas. Good afternoon, a very good afternoon to everyone. Am I audible clearly?
Yes, sir.
So today we are going to start a session on the topic of unmanned aerial vehicles for urban development. Uh, see, first of all, uh, why drone is becoming popular for urban development applications? There are several reasons. As you know, that urban population is increasing rapidly, and as a result, cities are becoming more important day by day. The urban population uh, is increasing and expected to be doubled by the year 2050. Many people are moving from rural areas to the cities continuously. This trend is anticipated to grow more rapidly in the coming years, especially in developing countries. This rapid increase in population in cities will create many challenges for city administrations striving to maintain and enhance the city's services and residents' quality of life. Uh, 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 More critical services are becoming necessary to be provided to the urbanites. And in the urban areas, this is basically a heterogeneous landscape, and there are a lot of features present in the urban infrastructure. Therefore, we need more spatial detail uh, about the urban landscape to understand the uh, relationship of various urban systems. And consequently, there is an increased interest in utilizing advanced information and communication technologies, robotics, smart solutions in the city developments. So combining all these things, uh, uh, UAVs are becoming more popular for the urban application and urban development applications integrated with GIS and remote sensing. Now, next topic is next question is, uh, uh, what are the urban application related advantages of UAV? First of all, accurate mapping is the mm, most important thing for the UAVs. UAVs can provide you very high resolution images. In India, as you know, that as per the government of India rule, no one can get satellite imageries of having spatial resolution greater than 0.5 meter. So maximum level of detail or maximum spatial resolution from the satellite images can be obtained at a spatial resolution of 5 meter, 0.5 meter, half meter. Now, as you know, that in the urban infrastructure, we have many features that are rather smaller than 0.5 meter. We have a lot of pipelines, several other things, and in the rooftops, several things are present. Urbanites use several illegal things that are even smaller than the objects that can be detected on the satellite imageries. And as a result, the satellite imageries are becoming less important for the analysis and for the applications of urban areas. So UAVs can provide extremely high resolution. What is the spatial resolution? It may be even less than 2 centimeter, down to less than 2 centimeter. Now, as you can understand that if the spatial resolution is less than 2 centimeter, that is almost the thickness of your finger or 2 fingers only. That means you can identify each and every detail in the urban landscape. Uh, Whatever the complexity of the urban landscape, it does not matter. You can get each and every detail. Other than the detailed information, you can also obtain DEM or DTM information. And more importantly, you are getting three-dimensional models of the urban infrastructure. Often, getting the top view or the image of the ortho image of the urban landscape is not enough, because urban area has another dimension, that is the third dimension, height. So many features are present in the urban area that have that not only have XY dimension, rather they have varying height information. And these heights play a very crucial role in several instances. I will try to address those instances later. So, accurate and precise mapping is possible by using the UAVs, and that was not possible earlier with the satellite imageries or even aerial photos. I mean, photos that were collected from the aeroplanes. Now, frequent update is another advantage at any time, on any day. If you want to get the imagery of a specific area, you can get the imagery. Mobilizing a drone may take even 10 to 15 minutes, just 10 to 15 minutes. So you can deploy the drone and you can collect the information, up-to-date information and imagery you can obtain. And as frequently as you want, you can get it. I mean, if you want to get the imagery every day, that is also possible, or multiple times in a day, that is also possible. Then another advantage is, access. UAVs can reach inaccessible areas or hard to reach accessible areas, and it can get the information of very narrow roads or very narrow urban spaces. It can reach the construction sites, and even, sometimes city administrators are not allowed to go inside of the building. They need several legal permission, and all several legal issues are involved in it. So whether someone is accumulating something on the rooftop, or is there any water logging in the rooftop or anything, investigating and inspecting these things may become difficult for the city administrators. But UAVs can reach those areas without having any restriction, and can obtain the information easily. So that is another advantage. Now, let me come to the discussion of the application areas. What are the application areas, or where the UAVs can be applied in the urban areas? Many of the applications are known to you, definitely. For example, for crowd monitoring, UAVs are nowadays being used. Crowd monitoring, see, crowd is a general phenomena in urban area. For several reasons, we face crowd in the urban area in different festivals. For example, in Kolkata, on 25th December, in the Park Street area, we have at least in a 2 kilometer road, it will have at least 10 lakh of people. So this 10 lakhs of people, monitoring this 10 lakhs of people is very difficult on the ground. But from the sky, it is rather easier. You can focus in different areas quickly, and the inspection can be done remotely as well. I mean, the city administrators can view it, or the legal administrations can view it from the remote location as well, without visiting the site. And the camera can be focused in different areas, different locations can be zoomed in or zoomed out. A larger area can be covered from the top of it. So there are several advantages. You know, perhaps all these advantages. So for the crowd monitoring, it is a very useful thing in several occasions. Drones are being used for crowd monitoring. Then we have urban environment monitoring, and we should be rather more concerned about the urban environment, because the urban environment is degrading continuously. Water bodies are filling up. Urban vegetations are being sacrificed for several developmental activities. So ultimately, it will be. I mean, the urban areas will become a forest of concrete only. So we don't want to make the urban area a forest of concrete. Rather, the urban environmental balance should be maintained, and therefore the water bodies should be monitored continuously. As you know, that urban water bodies, urban surface water bodies are more prone to be contaminated, because in the urban areas we have more pollution, and we are rather more uh, I mean more reluctant to maintain the water bodies. In the rural areas, the water bodies are in general, they're productive. They are producing something for agriculture or for fisheries. They are using those water bodies. But in the urban water bodies, if these water bodies are maintained by the government as a compulsion. In most of the cases, they are not productive. And if it is not productive, then we often forget about it, and we do not care about it. So this urban, as I told you, this urban water bodies and urban vegetation are uh, uh, highly degraded nowadays. So they should be monitored continuously. If we should monitor it, whether someone is throwing something on the in the water body, or someone is trying to fill up the water body. So continuous monitoring is required for maintaining the urban environment, and UAV can provide this information remotely. It does not require to visit the site, and I mean the political conflict or any other conflict will not arise in the ground. You can collect it remotely, and the people below will even uh, uh, not be aware that the data is being collected. So for the urban environment monitoring, it is very useful. Then civil security in several instances, you know, uh, to monitor or to uh, to identify the activity of criminals or the movement of some vehicles, etc. So for several reasons, the UAVs can be used for monitoring and inspection. Then asset mapping, in general, in the urban areas, we have many assets, like we have towers, we have buildings, we have even heritage buildings. So we have roads, we have pipelines, we have several other utility lines, drainage systems. So all these are necessary to be mapped properly, and UAV will help in this mapping activity, uh, since it can provide very high spatial resolution, as I told you earlier. Now, illegal construction is another major issue in the urban areas. It is actually not possible by the city administrator to inspect each and every corner of the city. And if a person has been allowed for the construction of two-story building, and whether uh, he is going to construct it in three-storied, or I mean any government land is being occupied by someone for the construction of structures, etc. So this can be monitored on regular basis, and even the data will be collected remotely, as I told you, and no one will know that the data has been collected, and someone is observing the things. So illegal construction can be monitored. Now taxation, in some of the instances, someone may say that I have constructed the building last year only, but perhaps it has been constructed 10 years back. So see, this type of conflicts can be avoided. Uh, who has constructed in which year? So all these records can be kept updated on regular basis. And as I told you, that UAV can provide this very detailed information. Even very small buildings or small structures can be identified very clearly. Then public health management is another issue, in several instances in older cities, we have waterlogging issues. Even, the urbanites use tubs and flower vase um, uh, on the rooftop or in their balconies. And waterlogging actually creates, mosquito breeding centers. And several diseases like malaria, dengue, etc., are spread by these mosquitoes. And monitoring the water logging uh, is rather easier in the outside of the buildings, but in the inside or in the rooftop, it is not possible to inspect. Each and every building inspection is never possible by the city administrators. But UAVs can reach in those areas and can get this information very quickly. So for public health management also, other than this, whether people are throwing the garbage here and there, so it's all these things can also be monitored. Now, solid waste management is another thing, whether proper collection of the garbage is uh, going on regular basis, whether they are being moved into the proper location, or what is the exact volume of garbage that can be identified and estimated, because UAV image processing also helps us for the volumetric analysis. Now in the dumping area, garbage dumping area, what is the volume, whether we need to arrange a new dumping station, or whether we should remove this garbage to accommodate the future garbages, etc. So all these estimation for all these solid waste management related issues, UAVs are very useful, and we are using the UAV in many instances for the solid waste management. Now we have the utility management. As you know, in the urban areas, we have several utilities like gas line, water line, and power line, etc. So whether they are in intact condition, in which areas we have these lines, in which areas we don't have these lines, or for the planning of new services in newer areas, uh, we need the detailed spatial data. So this detailed spatial data can be obtained from the imagery, in which areas population is increasing rapidly, in which areas new houses are being constructed rapidly, and we should provide these utility services in those areas. So everything can be planned by the city administrators for the utility management. Now, micro watershed analysis or water logging. Water logging is a common phenomena in older cities. So, because in the urban areas, almost everything is concrete. So, rainwater cannot penetrate through the ground. So, water logging becomes a pain to the urbanites. So we can analyze the watershed with, urban watershed with much more detail. This is the use of the UAV that is not possible with the other things. Like, for example, you are getting the free DEM, SRTM DEM of 30 meter spatial resolution. Now, 30 meter is very large area, but with the UAV, you can generate the DEM with 3 centimeter, 4 centimeter, or 5 centimeter spatial resolution. Or even with the LiDAR, you can get very detailed information. LiDAR sensor, you can get the very detailed information about the terrain. You can remove the buildings, you can remove the trees, and you can get the terrain information in a very high level of detail. And micro watershed analysis is possible if you have this type of detailed data of the urban areas. For the urban areas, even in several research papers, I have seen that many people have worked with the SRTM DEM and all. These are basically useless. In the urban area, SRTM 30 meter spatial resolution DEM is not at all useful. Because in these areas, if the waterlogging is in A area, and just beside of that we have the B area, and in the B area we don't have any waterlogging, because there are height differences, and also the sewerage differences will be there. So that is why we should go for the micro watershed analysis with very high level of detail. Centimeter level accuracy should be needed. Then for the traffic monitoring and management is another important thing. In the urban areas, as you know, traffic is a pain. People move with vehicles. The percentage of vehicle is normally higher than the percentage of roads, and as a result, traffic congestion is a common phenomena. So the traffic management administrators can observe the traffic. I mean, they can count the number of vehicles in different areas in different times of the day, and accordingly they can plan the routing of the vehicles, in which route, at what time the vehicles should be routed. That can be planned in advance, and accordingly better management can be done. Then is the drainage monitoring. It is a very important thing for the city administrators, because you have to ultimately remove these liquid waste from the urban area. Huge amount of liquid waste are generally created in the urban area. This liquid waste generally goes through the underground pipelines and all, but ultimately they are thrown in a channel or canal, and then this canal is used to transport this liquid waste. In several locations, several pumps are also used to suck this liquid waste. So what is the status of the liquid waste, whether it is increasing or decreasing because of rain? Is there any problem in this issue, in this case? So all these things can be monitored, and accordingly a better planning may be done, where we need to establish a new pumping station and all. That can be planned in advance. Then infrastructure inspection. UAVs can generate three-dimensional model of a structure. So any type of structure in the urban environment, it may be a statue, it may be a heritage building, it may be it may be any other thing, tower or bridge, whatever. So everything can be modeled in 3D. And video inspection can also be done, whether the structure is in proper condition or not, whether if we have a very large bridge, for example, over a river. So underside of the what is the condition of the underside of the bridge? What is the condition of the uh, structure? whether it is structurally safe or not. So all these things can be understood by using the drone, because a human cannot reach each and every location of a bridge, but the drone can reach all those areas. It can zoom in specific area. Even 48x zoom is also available with the modern drones. So from a distant, you can get very detailed information. Now, construction and monitoring and modeling. Construction monitoring and modeling. In several construction activities, what is the progress of the construction that can be inspected, that can be monitored, and if required, a 3D model of the under construction site can be constructed, and if we uh, uh, make this type of 3D models at as a certain time interval, then what is the progress that can also be monitored. And in the construction site, the UAV images can provide you the cut and fill analysis, how much how much material is required to fill a specific area, or how much area is necessary to be cut to make this area flat. So all these type of analysis are also possible by using the UAV images that was not earlier possible. Other than this, several other applications are also coming in future and also in existence. So I'm not going to make this lecture very long. Now, some potential future applications are also being experimented or under consideration. Uh, uh, the important, some of the important applications are delivery of food or medicine. See, in the urban area, because of the traffic congestion, often it takes much longer time for the delivery of food and medicine. So drone-based food delivery and medicine delivery is becoming uh, a new prospective uh, project. Now, health emergency services like air ambulance, etc., can be deployed in the urban UAV-based air ambulance system can be deployed in future. Then UAV-aided wireless communication in some of the areas, because of the high-rise buildings, signal blockage issues are faced by the urbanites in many cases, and many important events are even hampered by these communication issues. So for this type of cases, UAV based wireless communication systems can be deployed. Then air taxi is another thing that is being experimented. You know it already. Then public announcement or notice, UAVs can carry speakers, and remotely any message or any notice can be served to the civilians. Then for the crime management, it will be used for chasing vehicle or this type of activities. UAVs will be used in future definitely. Then air quality or pollution monitoring in this sector also, UAVs are becoming popular. So in future they will be used more widely, I think. See, land-based air quality monitoring is not always very useful, because just above of the land surface, there are several factors that will degrade the environment. But what is the environmental condition 50 meter above of the land surface, or 100 meter above the land surface, or even 20 meter above the land surface? So all these things can be well understood, and accordingly we may go for better preparation and better services to the urbanized urbanites. Next, integration with GIS. See, first of all, if we integrate the UAV images images or UAV collected data into the GIS system, it is it is known to you that the UAV images can be overlaid with the other GIS data layers. Therefore, analysis of different spatial data becomes rather easier, and the urban pattern can be well understood. See, on the GIS data layers having the vector layers, lines, polygons, points. Uh, they do not provide actually the real snap of the landscape. But if we get an ortho image, then it can provide much more detail. The urban area, I mean urban urban GIS data must be collaborated with the UAV images. For the urban planning also, UAVs are very useful. Planning of urban infrastructure, zoning, land use planning, planning of roads, cut and fill analysis, laying of new utility lines. So for all these things, UAV data will be very, very useful because of its very high quality. Then several urban services will be benefited by the UAV images, as I have already discussed which urban services can be benefited. In case of disaster management, urban disaster management also, UAVs are rather quick to deploy and to acquire the data. So integrated with the GIS data, disaster management systems can work in a better way. They can plan with a better way, and also they try to mitigate these disasters in future also. For example, if you have very tall buildings in just beside of very narrow roads, then definitely it is a threat for the firefighters. So if you have the appropriate data in advance, then definitely you may plan for it, what should be done or what not to be done. Even in firefighting also, UAVs are used for the inspection, and also in some of the instances to carry the hose pipe for providing the water. So in several cases, experimentally, UAVs are being used in the urban infrastructure. Now, integration with remote sensing. Now see, integration with remote sensing, remote sensing means collecting the data from remote. It is known to you. Anyway, so I'm rather going to discuss what are the remote sensing data that we can get by the UAVs. First of all, RGB mapping. Daylight sensors means those RGB mapping payload. So RGB or daylight cameras can provide very, very detailed information, and it can also provide three-dimensional mapping of the urban area. 3D information about the urban infrastructure can be provided. Urban structure, urban statue, urban heritage buildings can be mapped in 3D with the daylight and RGB mapping payload. LiDAR mapping is another thing. We can use LiDAR sensors in the UAVs. LiDAR sensor can provide precise elevation model, digital elevation model, and it can be used for micro watershed analysis or to assess the flood risk areas, or for the construction planning, or any type of other terrain analysis. LiDAR data are rather very, very useful. Other than the terrain related information, LiDAR data are also becoming very popular for the urban infrastructure monitoring and mapping. For example, three-dimensional mapping of a bridge, 3D reconstruction of a bridge, or any other statue or building or any structure. in the urban area can be done with the LiDAR in addition to the daylight mapping payload. Then multispectral cameras can also be used in the urban areas for the understanding of the vegetation health, urban green spaces, or open areas or green land covers. Multispectral mapping can be done, and their health or vegetation stress, urban vegetation health and urban vegetation stress can be analyzed in a greater way. You may find many research papers in the existing literature that many people are working with the urban infrastructure. What is the data that they are using? They are using Landsat data, they are using Sentinel data. Even if they are using very high spatial resolution data, that is also 5 meter, 6 meter spatial resolution or 10 meter spatial resolution. Now you just think, urban vegetation is not a contiguous phenomena. It is isolated. So the trees are standing in isolated manner. And if I have a spatial resolution of 5 meter by 5 meter, that is generally considered as a high spatial resolution anyway. So if I consider a 5 meter spatial resolution, see, perhaps the tree is not occupying 5 meter by 5 meter canopy. The tree crown size is rather less than 5 meter by 5 meter area. So in such cases, we are basically underestimating the vegetation health or vegetation quality. We may see the vegetation health as degraded in this case because the spatial resolution is coarser and other things are also coming within the pixel. So artificially, the vegetation will be shown as degraded, but in reality, the vegetation may not be degraded. Okay. So we need a very high spatial resolution. Now, if we are using multispectral sensors, see, multispectral sensors always provide lower spatial resolution in comparison to the panchromatic or daylight payload. But at least if we are using multispectral sensors from the drone, at least we can get 10 centimeter or 15 centimeter spatial resolution. That is much higher than 5 meters satellite image multispectral imagery. And we can get a much greater detail about the vegetation health or vegetation stress. So in that sense, I mean, it is not a generalized vegetation health analysis, rather it is UAV-based vegetation health analysis. Further, in case of multispectral cameras, since the sensor is deployed by us on the ground, so we can calibrate the sensor, and based on the calibration data, we can determine the actual reflectance of the object. But in the satellite imageries, we do not get the actual reflectance because the actual reflectance is affected by several atmospheric phenomena, scattering, absorption, then reflection, refraction, several factors are there. And they are influencing the incoming and outgoing energy. But see, these images are being captured from a very low altitude, 60 meter to 100 meter or 120 meter altitude. So atmospheric interference is rather very less. Further, we have the opportunity to to calibrate the sensor at the ground and later while processing the image. And as a result, you will have the actual reflectance value that is never possible to obtain from the satellite images. Now, thermal imaging, thermal sensors can also be used for identifying the heat patterns within the urban landscape, identifying the heat island within the urban landscape, or building energy efficiency or infrastructure inspection, power line inspection, transformer inspection. If there is any power leakage, that area will be rather hot and it will become appear brighter in the thermal imagery. So they can also be identified. So other than this, video capturing is another thing in the urban landscape. This capturing of video is useful for monitoring of several activities, as I have already mentioned. For example, traffic monitoring, crowd monitoring, etc., or for the inspection like bridge inspection, tower inspection, heritage building inspection, or any structural damage inspection. So in several instances, these videos will be used. I mean, not only the mapping, rather videos will also be very useful in case of inspection and monitoring. Next, what are the limitations? Okay, UAVs have several limitations, like they have shorter endurance time, etc. I'm not going to discuss the general deficiencies of UAV. Rather, uh, these are some issues that are especially related with the urban areas. Okay, so first is limitation in the size of the study area. UAV cannot cover a very larger area, geographical area. Now, you may ask, what is the actual geographic area we can cover in a flight? That depends actually on the UAV you are using. Okay. Some of the UAVs are even rotorcrafts, are even available with 90-minute flying duration with the idea forge. And if we are using fixed wing drones and then or hybrid drones, then we may even get more than 2 hours flying duration. So we have the 60-minute flying duration flights. Even in some of the smaller, in case of some smaller drones, you will even have 15 to 20 minutes flying duration. So that means it may vary. However, if you have 1 hour flying duration and if you are flying the drone at 100 to 120 meter altitude, you will have the spatial resolution of 4 centimeter to 5 centimeter, and you will cover at least uh, 2 square kilometer in a single flight. So it is not too small, but you have to understand that it is not like the satellite images. Okay, satellites can cover a very large geographical area because of its synoptic view. But in case of drone per day, with a drone of having 1 hour flying duration, maximum you may cover 6 to 8 square kilometer per day. So that is one disadvantage. Now, UAV controller communication issue is another issue, because in the urban areas we have the high-rise buildings. So the controller and the drone have to be in the line of sight. But it creates a huge communication issue in the urban environment because of the high-rise buildings. The UAV goes beyond of the line of sight, and communication failure we generally face. Now, see, if the solution is fly the drone from a top of a building, etc. These are the solutions that are generally provided. But flying a drone from the rooftop of a building is not a solution, because you may not get the access of the rooftop of a very high-rise building always. So if it is basically a wastage of time, and even you may not get the access at all. So flying from the rooftop is a solution, but that is not the ultimate solution. So ultimately, you have to face the communication issue. Then constant in processing of large volume of data, as you know that in case of drone images, they capture a very small geographical area because of high spatial level of detail or high spatial resolution. Therefore, for 1 square kilometer area, just I'm giving you an example to have you an idea. If we are flying the drone at say 100 to 120 meter altitude, then for 1 square kilometer area, you will have more than 1000 images. Okay. So if your a city is of uh, just 50 square kilometer area, then you will have 50,000 to 50,000 images. Now, all these images are necessary to be processed into the computer, and that means you have to handle a large volume of data. Therefore, you need a computer with very high processing power, large storage space, large memory space, large graphics cards are also required for processing of this data. Means, I mean, specialized computers means greater investment would be required. Now, information extraction techniques to be improved by processing of high resolution UAV data. Although a lot of proprietary and open source image processing, drone image processing software are available in the market, but they are still not very efficient, and they needs to be improved a lot. Why? Because they cannot handle this huge volume of data. For example, if I want to process the UAV image of say 50% of even West Bengal, even 50% of the state of West Bengal, it is not possible. Okay, with the current version of computer and software technique, it is not possible. Absolutely. That means we need some future development to handle this huge volume of data. Collection of data is not the ultimate thing. Finally, you have to extract the information from this data. Then, tough regulations are also there across the globe. And in some of the instances, it is even unregulated. And as a result, collecting the data and then getting the information from the data is rather difficult. Using AVs in cities may require them to operate within the airspace that is utilized by the regular manned aircrafts that is used by the military, police, cargo, civilian passengers. Normally within the cities, you will have airport and one or more airports. And definitely manned aircrafts will be there. So as a result, UAVs cannot safely operate within any city without having specific regulations defined and properly enforced. You cannot fly the UAV as you wish because there are some other flying objects in the sky. Currently, some governing bodies have put thorough regulations involving airspace use, communications, licensing, and certification, and all. These regulations create and enforce some level of control on UAV use, and it is expected to be more formulated in near future. But still, it is not very uh, 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 very well formulated, and it is not very user friendly. So this was all in brief that I would like to convey you. Now, if you have any question, you may ask. Someone has asked, how can UAVs be utilized to monitor and manage urban green spaces effectively? First of all, see, in case of monitoring, we have two different types of monitoring. One monitoring is the video monitoring, and another monitoring is the image monitoring. UAV can provide both type of data, videos or images, ortho images. Now, if we can get the imagery, then multispectral imagery, then the urban vegetation health, urban vegetation stress, etc., etc., can be analyzed very effectively. I mean, it is not comparable with the satellite image related NDVI or something. Rather, this information is very precise, and it concentrates on a very smaller geographical area. So the error percentage, or I mean the assumption or whatever you say, that is the scope of error is very less over here. And I have already mentioned that multispectral sensors can be calibrated in the ground. We can extract the actual reflectance, and as a result, whatever we calculate from the multispectral imageries, whether it is vegetation index or vegetation health or vegetation stress or whatever, everything will be much more accurate in comparison to the satellite imageries.
Thank you, sir, for this wonderful session. I hope everyone found the information valuable and engaging. So now we would like to move on to the question answer session. Here are some of the questions coming from the students. I would go on one by one. So first question is from Tuhin Pal. How can UAVs be utilized to monitor and manage urban green space effectively?
Yes, Aniket, I have already replied
Just
this
answer the
question.
question.
Yes, I got the answer, sir.
Yeah, you can move to the next question, Aniket.
Okay. So second question is from Soham Das. Local climate zones classification plays a significant role in managing urban heat islands and micro level climate study. How can UAVs engage in this prospect for identifying the various classifications?
Yes, definitely. UAVs are rather more powerful for the thermal heat island analysis and all. Why it is more powerful? Because it can provide very high level of detail. Normally, normally we get the thermal imageries from the satellites. What are their resolution? Their resolutions are 60 meter, 120 meter. Now think in the urban infrastructure, the landscape is changing in every centimeter. Okay, or in every few centimeter. How can we use 120 meter or 60 meter spatial resolution data for the analysis of urban heat island and the classification of urban heat island? In case of thermal imagery, although, as I told you, thermal sensors can provide lower spatial resolution, UAV-based thermal sensors are also not an exception, but they can provide a spatial resolution of uh, 10 to 20 centimeter. So if I get the information at 10 to 20 centimeter, then definitely I can identify each and every thermal detail on the landscape. Even a transformer is generating higher temperature, that can also be identified. AC machines can also be identified. Uh, in which area uh, higher temperature is being produced by the uncontrolled use of air conditioning machines and all, that can also be analyzed by using the UAV images. That was never possible by using the satellite images. And if we have a very high level of detail, then definitely we can classify them according to the level of temperature, uh, and radiometric calibration of thermal image is also possible. So radiometric thermal data we can obtain radiometric thermal data. Radiometric thermal data means we can actually measure the temperature, radiant temperature of the Earth's surface. So direct measurement of the temperature is also possible by the UAV data. Aniket, I can't hear you.
Sorry, sir. So we move to our next question. Considering the advantageous features of UAVs, should we fully rely on them for fetching accurate critical information and depend on its reliability?
Yes, definitely. Definitely. If we can rely on the satellite data, if we can rely on the data captured from aeroplanes, then why not from UAVs? UAV data are collected from 60 meter, 70 meter, or even 100 meter or 120 meter altitude. So they can provide much more detail. As a result, they are much more reliable.
Okay, so sir, there is a fourth question, that is, how do you address privacy concerns related to UAVs flying over urban areas? It is from Kostav Pramanik.
Yes. First of all, see, the privacy is always respected within the boundary of the wall. Okay. Outside of the boundary, outside of my the boundary wall of my building, I cannot uh, ask for the privacy. Rather, I'm being monitored. Urban areas are rather more monitored in comparison to the rural areas. In the urban areas, you may find one camera in every lamppost, perhaps. So, lot of eyes are continuously monitoring you. Why they are monitoring you? See, don't think it in negative way. They don't want to steal anything from you. Rather, these monitoring activities are being conducted just to provide you better security, better services. So, privacy, see, in the outdoor, we do not demand for the privacy. Indoor, you are definitely secured. No one is going to steal your privacy. UAVs can UAV is also not capable to steal this privacy. But outdoor uh, uh, in the urban area, you cannot demand for the privacy because in the urban areas, urban infrastructure, urban services, urban safety security are much more complex. I think we should ask for, we should demand for continuous monitoring rather than blind privacy.
Okay, so our next question is, what are the potential cybersecurity risks associated with the use of UAVs in urban data collection?
Cyber security.
Yes, sir.
Yes, cyber security is definitely a concern. See, the data that are being collected by the UAVs have gone through several such type of discussions and threads. And nowadays, the government of India has uh, 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 framed a rule that no UAV can be imported from outside of India. So all of the drones must be manufactured in India by following drone rules 2018 and subsequent amendment in the 2021. And in the drone rules, several things are there, to maintain the safety security of the data, encryption of data. There are several manufacturers who maintain a very high security of data while capturing the data and while storing the data. So even the militaries are also using these Make in India drones and they are uh, uh, using their uh, uh, encrypted safety security issues, and they are not facing any challenge. So if it is encrypted properly, if the data is encrypted properly, if it is manufactured by using by following the rules framed by the government of India, I think there should not be any we should not have any concern of cyber security issues, at least at the capturing of drone or storing of data in the drone or transferring the data from the drone to the control station. Okay.
Okay, so our next question is, how can drones equipped with thermal cameras be used with GIS to inspect buildings after a natural disaster? And how can this improve response systems?
Yes,
It is from
thermal. Uh,
Shayad Bhattacharya.
yes, see, thermal sensors do two basic things. One thing is temperature mapping. That means I'm measuring the temperature. What is the temperature at what place? This is a straight temperature mapping. Another is analysis of relative temperature, where we have the higher temperature, where we have the lower temperature. So in case of disaster, for example, in case of collapse of a building or collapse of a bridge, etc. So what are the primary threats that we face? The primary threat is basically the loss of human being, loss of lives. So the first thing is, the rescue team, what the rescue team does, they try to find out if there is any life. So life means basically it is hotter. It has normally it has a high temperature in comparison to the other objects. So if we can find uh, higher temperature in a disaster area, then we may have lives over there. So we may go for those areas, or even we may send dogs on those areas, and a rescue operation can be rather faster. See, in case of an accident, or in case of a disaster, a building collapse or bridge collapse, it is not possible for us to identify the human being below of the bridge deck or the slab. So the temperature mapping can help you in some of the instances. Definitely, it is not the ultimate tool, but it may become one of the tools to find out the lives.
Okay, so I move to the next question, sir. Can UAVs be rapidly deployed after heavy rainfall to map the extent and severity of urban flooding, providing real-time data for emergency response efforts in cities? It is from Aniket Mitra.
Definitely we can fly. See, first of all, when it is raining, then it is not possible to fly the UAV because in India we do not get any till date we do not have any drone that is fully rainproof. So the drones that we have, they can tolerate the diesels, but they cannot handle heavy rainfall. First of all. Second thing is, we are basically using cameras in the drones, whether it is a video camera or mapping camera. So if we have a heavy rain, then definitely the camera will not be able to see the objects. So from that point of view also, it is not at all useful. Now, just after the rain, if the sky, if enough light is there, and there is no, I mean, there is no raindrops, then definitely we can fly and we can get the real-time data of different locations, water logging, or how the people are being affected affected, which buildings have emerged up to what level. So everything can be mapped.
Okay, so our next question is from Sohili Shaha. Can you share examples of successful collaboration between UAVs operators and local governments for urban planning and infrastructure development?
It is rather more administrative question. UAV, see, the government of India has framed several rules for the UAV operators. Uh, 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 they have also the piloting licenses from the DGCA. So before flying a drone, you should have the appropriate piloting license certified by DGCA. Then local authorities also, nowadays they are also aware in many of the instances. So we intimate the local police station. Local police station uh, also knows when the drone is going to fly, for what purpose it is going to fly. And government agencies who are providing these jobs to the private organizations or other bodies, they also inspect that whether the organization is complying all the guidances set by the government of India. So nowadays it is rather more, more systematic rather than chaotic, but definitely it is not 100% systematic till date. Uh, uh, Tough regulations are also there. Permission from several levels may be required in case of some complex issues, some border areas or protected areas or reserved areas. So still we have to go miles away, but things are becoming more systematic day by day.
Okay, so we have a last question, sir. Can you elaborate the role of AI and machine learning in optimizing UAV operations in urban settings?
See, uh, artificial intelligence and machine learning is basically in the background of the UAV image capture, UAV image processing and all. First of all, if you are aware of drone mapping, you may know that you are basically defining the area in which area the uh, uh, mapping should be done, and at what altitude you want to fly the drone, and what kind of overlap you want, 80% overlap or 70% overlap, 60% overlap, etc. So if you define these things only, then the software intelligence will define everything, the flight line and all. What is the interval of the mapping? I mean, intervalometer will be defined by the software automatically. Now, as you know, that UAV is not moving at a constant speed. It is moving with a varying speed. Why? Because when it has to take a U-turn, then it has to reduce the speed. Or the air maybe air gust is creating issue. It is pulling the drone, or it is pushing the drone. So there may be several reasons, and that is not constant. For example, air gust. Air gust is not constant. So that means the captured images, there will be different gaps in between the images. But I have asked for a specific overlap, for example, 60% overlap or 70% overlap, say. So that means the overlap will be different. No, the overlaps will not be different, because based on the speed, based on the resistance, based on all these things, the computer system is continuously working to maintain this gap, exposure station gaps constant. So several technologies are being used. Now, in case of an emergency, for example, battery balance issue, uh, battery voltage down issue, uh, heavy wind issue, heavy rain issue, high temperature issue. For several issues, safely the drone will come back and will land at the home location. No one is going to measure the temperature. No one is going to measure the wind speed at the level of drone. So there are several sensors. They are working continuously, and artificial intelligence is controlling everything. Everything by AI and machine learning is controlling for the safe operation of the drone. Now, there may be several obstacles, hilly areas, maybe there, tower, chimney. So the obstacle avoidance capabilities should also be there within the drone. So several sensors, they are also continuously feeding the data into the system. The data is being analyzed continuously while the drone is moving. And if required, the braking is braking is done, or the path is changed. So all these are definitely maintained by artificial intelligence and machine learning. And when we are processing the data, if you have learned the drone image processing, then you might have seen that it is mostly automated. We have to align the images, we have to generate the point cloud, we have to generate the DEM, DTM, ortho image, 3D textured model, tiled model. So all these things are not created by the human being. You are just giving the command, align images, and you just sit back and have a cup of tea. The machine learning, how, see, these thousands of images, as I told you, for 1 square kilometer area, there will be more than 1000 images. So these thousands of images will be stitched. While captured the imageries are captured in perspective projection. But from the perspective projection, this individual perspective projection from the individual imagery will be converted into orthographic projection. Means just the top view. See, in the ortho image, building sides will not be visible, only the building top will be visible. So all these things, all these things are being performed within the computer system, and it is fully automated. So everything in drone image capturing, mission planning, flight control, and post-processing are done by artificial intelligence and machine learning. Human intervention is required in very few instances for getting a better output, definitely. But without having human intervention, you can get uh, most of the data.
I think that was the last question from the student side. Is there anything else, students? Do you have any other questions, please? Aniket, do we have any more questions? I think that's all. Now, good evening to everyone present here. I am Bhakti Thite, and I take care of the placements of the students. And on behalf of SIT, Symbiosis Institute of Geoinformatics, I extend a heartfelt gratitude to everyone who contributed to the success of the event. First and foremost, I would like to express my sincere thanks to the esteemed guest speaker today, Dr. Basudeb Bhatta, for sharing your valuable insights and expertise. Your extensive experience and expertise in this field has provided the students with a deeper understanding of how UAVs can transform urban development and data collection. Plus, you have helped them to understand the basic concepts like how refractions and reflections sort of challenge the process of image capturing. I would also like to extend my heartfelt thanks to esteemed Director Dr. T.P. Singh sir and Deputy Director Dr. Vidya Patkar ma'am, also the HOD for Geoinformatics department, for the unwavering support and encouraging this event. I also thank the technical and IT department for the planning and execution. Their hard work is always behind the scenes. They always ensure that the process is conducted very smoothly. Additionally, I would like to not forget, I would like to, comprehend Soham Das, Gaurav Rana, Tuhin Pal, and I must also thank the webinar committee, which is headed by Asmita Banerjee, for her hard work and proper planning. I would also like to extend my gratitude to all the students who have been present and patiently listening to the webinar. I must say that the active participation through question answers has, enhanced the quality of the interaction. Once again, I would like to thank Symbiosis for providing the platform for students and the support which was given to them for conducting this webinar smoothly. I can assure you that for the upcoming placement season, this is definitely going to help the students in understanding things because they have got a practical insights of how drone works and how these kind of things happen in the background at a practical base. So once again, I would like to thank everyone who made this event success, and thank you, sir. Thank you, everyone.
Thank you, ma'am. Thank
Thank
you,
you.
all of
Thank
you.
you so much. Yes.